My name is Alison and I will continue with homeostasis. Definition. Homeostasis is the process by which organisms maintain a constant internal balance despite changes in the external environment. It is essential for the survival and proper functioning of the human body. Importance. Homeostasis allows cells, tissues, and organs to function effectively by maintaining stable internal conditions as body temperature, blood pH, and glucose level. Example: regulation of body temperature through straining and vasoconstriction, regulation of blood glucose level through secretion of insulin and glucagon, and regulation of blood pH through respiration and kidney functions. Regulation of internal balance refers of the state in which the body's physiological conditions are managed with optimal ranges for cellular functioning. Negative feedback. It is mechanism in which a variation in a variable triggers a response that reverses the initial vari- variant to restore balance. For example, regulating body temperature through wind and cooling. Example, the regulation of blood glucose through the action of insulin and glucagon, and the regulation of blood pH through respiratory and renal compensation. Homeostatic response to stimuli. The body responds to change its the internal and external environment through homeostatic mechanisms that restore balance. Example: sweating to cool the body in response to increased environment temperature, the rise of insulin to reduce blood glucose after a meal, and the secretion of stress hormones in various situations. Main regulatory system: autonomous nervous system control involuntary functions of the body such as heart rate, breathing, and digestion. Regulated homeostasis through the feet of flick responses and the resistance and digestive response. Endocrine system: it is made up of glands that produce and release hormones that regulate various body functions such as metabolism, growth, and reproduction. Kidneys regulate fluid and electrolyte balance, eliminate metabolism fat, and control blood pressure by regulating blood volume. Chi- Challenging factors: illness, environment changes, physical of emotional stress, and nutrient imbalance can affect the body's ability to maintain homeostasis. Example of disorders: diabetes mellitus, dehydration, metabolic acidosis, hypothermia, and hypertension are examples of disorders that result from altered homeostasis. My name is Alison and I will continue with cardiac muscle. Introduction: cardiac muscle is a specialist muscular tissue that forms the heart, the central organ of the circulatory system. Function: the heart muscle contracting rhythmically to pump blood through the body, supplying oxygen and nutrients tissues, and removing waste products. Structure: it is made up of cardiac muscle cells called myocytes with a electrically interconnected to coordinate cardiac contraction. Cardiac muscle anatomy are made of actin and myosin. Sarcoplasma reticular is less fluid stored. Physical of cardiac muscle. Regulation of the cardiac muscle. Internal balance of the heart muscle needs to maintain a balance between the supply of oxygen and nutrients and the demands for work, especially during contraction and relaxation of the heart. Negative feedback. The heart uses negative feedback mechanisms to regulate its rate and force of contraction, ensuring adequate backflow to tissues. Cardiac contractions. The contractions of the heart muscles is constrained by an internal electrical system that initiates and contractions and heartbeat responsive to stimulate the cardiac muscle responsive to changes in blood pressures, oxygen and carbon dioxide levels as well as signaling for the nervous and endocrine systems. Heart disease disorders such as coronary heart disease, high blood pressure, heart failure, and heart rhythm disorders can affect the ability of the heart muscles to maintain homeostasis. Risk factors such as obesity, smoking, lack exercise, and an unhealthy diet can increase the risk of heart disease and disrupt cardiac homeostasis.
Hello, I am Dianara Gutierrez Mamani, and I will tell to you about the synapses. Uh, all right. Uh, you come with the synapses is a space between the needs of the neuron and another cells. Never impulses are usually transmitted to neighboring cells from chemical called neurotransmitters. The synapses neurons have the ability to communicate wide age of and wide effort chills to semantics are involved in each communication, never impulses, conducts, and synapses transmissions. Synapses from the different contacts have initiated well direct contacts. Alright. Um, according to their morphology, synapses are classified as axodetric, axomatics, axosonics, dendrodetic, dendrosomatics, and somatosomal. The last three are exclusive to CNCs. Synapses can occur A. about a neuron, B. between neurons and receptors, C. between neurons and muscle cells, and D. between neurons and okay, there is let's say 8 times of neurons interaction. A complementary electron arise there is at the let's say 9 times of neurality interaction. Electrodes are clumps occurs between cells, neutrons, graves, positive concepts of cylindrical connection by force for metallic bolts and smith ions. Permeability is regulated by pH, calcium, and Cam. The entry of cadmium and photon into cellular relation closes the pores while an increase in Cam opens them. This allows bidirectional flow or current between neurons and astrocytes in CNS. Alright, want electrical synapses. Electrical synapses is in a stem of connection. There is an separation of the brain to Trent and me. Separation pre and post synapses elements. The ionic current passes directly and withdraws the light to the index neurons. This is characterized big pressure six reduction state is concurrent passes on direct periphery. Electron synapses are alarms anaphylaxis in mammals. Both some have been described in the vestibular nuclei of the brain stem, retina, and cerebral cortex. 2. Chemical synapses. El chemical synapses in their own hormone chemical messenger neurotransmitters are released from the axon terminals. Chromes and synapses clays in embed two specific receptors on the spotphoenix membranes. This reduces the great varieties of neurotransmitters. They can be related synapses of the can are amongst the neurons in the head stimulus brain. They are unidirectional interaction. These chemical signals on of the specific membrane to the exponential membrane. Citrate reciprocal synapses is they are specific thermal synapses of the session polyartry for the entire written the page of exact story and inhibited signals is possibly receptor current synapses have been located in the afterreal. La combined synapses is una neural interaction that consists of the chemical synapses in an electronics coupling at the same time. The presence of this lead type of the synapses makes the interaction bidirectional. La metaxis synapses it is the presence of chemical synapses in an electrode. La synapses through head it is allows the neuron to have a false command span, electron synapses, and another reliability show both locations on mathematical signals are unidirectional and keeps a story in it. Serial synapses corresponds to a unsaid chemical synapse bed. There are more cells. Is allows effects on the postsynaptic neurodevelopment. Chemical modulates of an electric home. In its case, coaxial are modulates by chemical synapses on them. Them are both effects. Depends on the messenger who set the model neuron. For example, denominate unicellular the retinal cells while gamma's aminobutyric acid gave increases the gravity of coating in this same cell. Signal transmission is unidirectional and can be excistory or inhibitory. Fine. Autopsies. There is chemical autopsies of a cell from it is being prevent and vitreous culture of innocent neurons, which after 8 days contacts air extension with small bells. It is not called water. The signals are inhibitory of existory. Right. Yes, eso.
Hello, my name is Janaina and continuing, I am going to talk about the glial cells. What are glia? When we refer to glia, we are referring to glial cells that were classically considered as structural, metabolic, and trophic support cells for neurons without actively participating in the information process of, of this nervous system. What are glial cells? Oligodendrocytes, ependymal cells, Schwann cells, microglia, astrocytes. Astrocytes. Astrocytes are the most abundant glial cells in the nervous system center and are closely associated with neurons. The name astrocytes refers to their star shape when observed in histological preparations. Astrocytes provide structural support by defining cells boundaries, contribute to the formation of the blood-brain barrier, surround synaptic junctions, and because in the central nervous nervous system there is no basal lamina covering myelinated axons. Oligodendrocytes. Oligodendrocytes are cells that form the myelin layer that surrounds and protects the nervous tissues of the brain and the spinal cord. They are only found in the central nervous system. Ependymal cells. Ependymal cells or tanycytes are part of the set of neuroglial cells of the nervous tissue. They cover the ventricles of the brain and the ependymal duct and show multiple cell subtypes identifiable by their morphology. Ependymal cells possess latent neural stem cell potential. Schwann cells. The Schwann cells that constitute the glia of the nervous system periphery in addition to being the structural support for the axons in said system as the function of producing myelin and organelle of the great importance in neuroconduction process. Microglia. Microglia are cells of the central nervous system that function as elemental of the immune system, protecting the body from external and internal aggressions. The body defends itself against external aggressions. Example, viruses and bacteria among others, and external aggressions, example, cancer, strong the immune system. Thank you so much to arrive to unity here. Continuing, now we will talk about the muscles, skeletal muscle. Skeletal muscle is a type of striated muscle attached to the skeleton formed by elongated and polynucleated cells, which locate their nuclei in the periphery. These types of muscle obey the organization of actin and myosin proteins and that give them that striations that is seen with the microscope. Their determining movement and maintain the bone joint connection through muscle contraction. They are voluntary contraction through stimulation of the nerves innervation, although they can be contracted involuntarily. Okay. Muscle contraction. Muscle contraction. Skeletal muscle contraction is a highly coordinated process that begins with the propagation of a nerve signal from the central nervous system to the muscle via a motor neuron. The muscle contraction process can be divided into several stages. Nervous stimulus. When the nervous system sends a signal for a muscle to contract, the signal travels along a motor neuron to the neuromuscular junction where acetylcholine, a neurotransmitter, is released into the synaptic clefts between the neuron in the fiber muscular. Action potential. Acetylcholine binds to the receptor or the muscle fiber membrane, triggering an action potential on the cell membrane. This action potential travels along the membrane and through the T tubules, traverse tubules, which are invaginations of the cell membrane that allow the action potential to penetrate the interior of the muscle fiber. Calcium relays. Action potential propagation along the T tubulus stimulates the release of calcium ions from the sarcoplasmic reticulum, a calcium storage system within the muscle cell. Calcium binding to troponin. Released calcium binds to the troponin protein in the thin filament, causing a conformational change in troponin that in turn allows myosin to bind to the active site in the thin filament. Cross-bridge formation. Myosin binds to the active site on the thin filament, forming cross bridges between the actin and myosin filament sliding. The myosin head moves, shortening the length of the sarcomere, the contractile unit of the muscle, which produces muscle contraction. Hydrolysis of ATP. The energy necessary for muscle contraction comes from the hydrolysis of ATP to ADP and inorganic phosphate. This process provides the energy necessary to move the myosin head and allow muscle contraction. This contraction process is repeated continuous as long as there is nerve stimulation and ATP invaluable to supply energy. When nerve stimulation cesses, the concentration of calcium in the muscle This creases and the actin and myosin filaments separate, allowing the muscle to relax. Thank you.